Hello everyone, my name is Abhishek and I am an electrical engineering graduate student at the Arizona State University. Today we are standing in the Power System Research Laboratory in collaboration with Dr. Yang Wing. With the increase in the pollution levels and the demand for energy, there is a need for integration of renewable energy resources. The major drawback of renewable energy is the problems associated with the grid interconnection, their uncertainty and variability. To tackle this issue, we are going to demonstrate a microgrid controller, some protection devices, and how we can interface them to make the grid reliable and safe. The module has been interfaced to a power transmission and distribution model, some microgrid controllers, and some protective relays.
Everyone. My name is Ravi Kumar Patel and I am a graduate student at Arizona State University. Right now we have one transmission line model and distribution line model, and each side is connected with protective system equipments. So in transmission line, this is the sending end side and this is the receiving end side. And we have over here 3-phase load circuit and a circuit to create fault on distribution side.
The SEL 3555 RTAC, or the real-time automation controller, acts like the brain which controls the entire protection system. Different devices can be connected to RTAC for the purpose of protection. Right now we have used an Ethernet protocol and connected the SEL 351S relay via an Ethernet switch. For a visualization of the available protocols and the number of devices that have been interfaced with the RTAC, we have connected a monitor to the RTAC. Under the normal operating conditions, it can be seen that the relay is in its healthy state. The major advantage of using an RTAC is that it is possible to remotely control your protection system using a simple click of a button using the RTAC accelerator software. So in this example, we will demonstrate how we can provide a trip signal to the 351S relay using this software. All we need to do is that we need to go into the SEL 351S, which has been connected via a DNP protocol. So when we enter the controller tab, we can verify that our RTAC is communicating with the 351S. So when you expand this, you see that the status of the offline button is false, which implies that the device is communicating, and we can see the exchange rate here. Now we go to the tags and we have configured the binary bit 10 in order to issue a trip signal. So we will toggle it to true. Now to see the LED, we can go to the binary output, which is the 0th bit, and issue the true signal there also. On the relay, you can see that the trip signal has been issued.
You can see now I have powered up the circuit and connected a 3-phase load with the distribution circuit. Now come here, let's see how much current is flowing through the circuit as well as what is the voltage level at the terminal. Apart from this phasor representation, we also have SEL 735, a quality meter, which is shows that how much power is delivered to the load. Let's send relay setting to the relay. We are here using a accelerated quickset software manufactured by SEL, and we are sending relay setting to the relay SEL 351S. So now we have also configured our relay with instantaneous overcurrent trip. Line to ground fault and see relay is going to trip or not. A line to ground fault at C phase, we can see LED C is triggered. We have gathered a fault event through accelerated quickset. And now we will visualize the fault event. As we can see over here, we have normal fault current which is balanced, and over here, as we trigger a line to ground fault at C phase, so we can analyze a fault current over here which is around 10 ampere, which is quite more than the normal load current. As well as we can also analyze a voltage sag at phase C.
One advantage of using SEL351S is its inbuilt functionality to be used as a PMU.
So, to use PMU function in SEL351S, we also need SEL2401 as a synchronized clock.
The SEL351S generates timestamped events on a minute basis, and to log the same we have used the SEL3573 phasor data concentrator. To configure and visualize the data that is logged in the SEL3573, we use the PDC Assistant software. Once you log into your PDC Assistant software, you can monitor the real-time data under the status tab. Here you can see that the connection state is receiving data, and it's also displaying the number of data frames that are being received per second. The time quality is normal, which implies that the clock and the PMU have been synchronized properly. When you expand the input PMU, you see that the voltage and the current magnitude can be observed as recorded by the PMU. It is possible to check the logged files. So we go to the path that we had specified to store the logged data, and we open the current file. We can use the SynchroWave event software to analyze the data that has been logged. You see the phasor diagram. You can also perform various calculations depending on the need. I hope this video was informative as far as the functioning of the microgrid is concerned, and the associated protective devices such as the relays, PMUs, and the real-time automation controller.
And we would like to thank Arizona State University and Schweitzer Engineering Laboratories to provide a great facility to learn about this advanced equipment.